Hi, welcome. This is Unit 0, the part of the research. We've already covered, in a different video, I covered experiment and what is an experiment, what is an independent variable, dependent variable. In my personal opinion, this is going to be a lot easier. This video is going to cover non-experimental type of research. Now remember, the experiment is the only form of study that establishes cause and effect. So what that means is that everything I'm about to teach you does not establish cause and effect. So what we're talking about is descriptive research. I don't think you need to know this term, but we're just describing what we see. We're not doing anything. We're not manipulating a variable. So we're going to go over all of this stuff, the case study, correlational study. We're going to go over all of this, and you need to have all of this memorized. Okay? So the case study. So let's say you run into somebody who's basically a freak, somebody who has the worst case of amnesia in the world, like Clive Waring, if you know who he is. I hope you do, but if not, he has the worst case of amnesia of anybody. And so if you wanted to study amnesia, you might could just study him. You'd write a whole book on him, just one book on him. It might take you a few months to do. You write a 200-page book on him, and you study him in depth. That's what case studies do. If you're a sociologist trying to study school shootings, you may go and do interviews. You may spend months and months, not years probably, but maybe, I don't know, but you would interview people and you would try to really dig in deep about one thing. That's a case study. When you study something in depth. Now, you're not trying to establish a cause and effect relationship. You're just trying to really study something in depth. Now, the good part is that it goes in depth, but the bad part is that you cannot generalize what you find to everybody in the rest of the world. Okay, that's the problem. Just because something is true with Clive here doesn't mean that you can generalize that to every amnesia case in the world. He was special. But case studies do provide insight, though. Okay? All right, moving right along. Longitudinal studies. So if you were, say, a developmental psychologist and you want to determine, how do people change over time, one good way to do it is to study them in the second grade, then come back every 5 years and study them again. Give them the same test every 5 years, same test every 7 years, whether it's an IQ test to see how does their intelligence change over the years, or give them, say, the Big Five personality test every 7 years for 35 years to see if personality is stable. Now, this isn't the only way to do this. Obviously, the problem is that this takes a long time, hence the word longitudinal. But it's really good for some things because you're studying the same people. Okay, because when you study different people and different samples, you're going to get some variation, and it's good, it's bad. But the point is that longitudinal studies are good for studying change over time, especially if you want to study, say, developmental psychology or how do people change over time. Again, no cause and effect, just change over time. The problem is that these studies can take decades, long time. They take so long that their assistants take over when the head scientist dies, or maybe their kids take over. Okay? Cross-sectional study. So, this is so much easier than a longitudinal study. Let's say you want to study personality differences or IQ differences between second graders and fifth graders and eighth graders. So what do? You go over to the elementary school, you give a test to the second graders, and then you walk across the hall and give it to a bunch of fifth graders. and then maybe drive down the street to the middle school and give it to a bunch of 8th graders. You could be done in a couple of weeks. This is called a cross-sectional study. You can study different ages, like I just described. You could study different races. For example, how are Latino attitudes towards psychotherapy different than, say, African American versus whites? And let's get out of America. Let's talk about how are people in China, how do they view psychotherapy versus how people in Germany do? Cross-sectional, you can study different incomes, different races, different regions of the world. That's what cross-sectional studies do. Okay? So longitudinal, you could do that with the same people, but then but longitudinal, it takes decades. Cross-sectional, you can be done in a couple of weeks. And they all have their advantages and disadvantages, but cross-sectionals are a lot faster. Okay, all right, moving right along. Okay, now keep in mind that surveys are just a tool. They're not a method. And I think that's going to come in handy later on in this course. But write this down. So a survey, I could do a survey in a longitudinal study. I could do a survey in a cross-sectional study. But what are the pros? What are the good stuff of surveys? Well, first of all, they're cheap. They don't really cost a lot as far as science goes. They're fast. You can be done with them in a week or two. And they are accurate if you have a random sample of the population that you are studying. Okay, you can't just go to a local mental hospital and study the people in there. You got to study everybody that you want to study. Okay. Cons. One problem with surveys is that people lie. We call that the social desirability bias. I'll go into that in a second, but basically people don't always tell the truth on surveys. I mean, if I were going to ask people, how gay are you? You know, people are going to lie. How often do you have diarrhea? People are going to lie, or they may not know. Another problem is low response rate. Who answers their phones anymore from strange numbers? And sampling bias, very important. If you're going to do a sample, you gotta make sure that it includes everybody, not just a certain sample of people. Okay. All right, moving right along. So, random sampling says that, like, let's say you want to find out what your school thinks. Okay, what does your school think about a certain topic? Like, who are you going to vote for in American politics? Who are you going to vote for? Well, you can't just go to the senior section and ask your friends. You need to have a random sample. You need to have everybody having a chance to be a part of it. You can't just go up to your friends. Otherwise, you'll have a sampling bias. Think of it as you have Chex Mix with nuts and M&Ms and everything, and you're trying to get that perfect bite. You want a mix of everything. You don't just want just one thing. Okay. All right, we already wrote this down earlier. Okay. Social desirability bias, meaning people lie. For example, think about infidelity. 20% of men admit to an infidelity while 10% of women do. So does this difference mean that somebody's lying? I don't know. But the point is that can you trust people to tell the truth in a survey on infidelity or sexual orientation? You know, I mean, so anyway, we call that social desirability bias. All right, moving right along. All right, so I mentioned sampling bias earlier. It needs to be a random sample. You can't just go to your friends in the band hall. You got to ask all kinds of people. You got to put everybody's name in a hat in the entire school and randomly select their names. You can't just go up to your friends. Okay? You can't just go ask the football team. You need to ask everybody, or at least a random selection of everybody. Okay? All right, naturalistic observation. You just take a notepad and you watch people in their natural environment. Go to the state fair or go to the mall and just watch people and write down what you see. And you don't get involved in anything, you just watch. So the benefit, you're watching them in their natural environment. However, the bad part is that we are biased people. We might be a little racist or sexist or something. And that may affect what we write down. Okay. All right, moving right along. This is, all right, write this down, meta-analysis. So let's say I want to know if vaccines cause autism. By the way, that's that's a reasonably common idea that a lot of people have in this country. And this is way before COVID and anything. People think bad things about vaccines. So let's say you find a study, and this one study says, no, vaccines do not cause autism. Well, that's great. But what if I took 22 experiments and they all said that vaccines do not cause autism? And then I combined all of the results into one meta study. Now that's powerful. If you can find 22 different studies that come up with the same conclusion and you combine them into one meta-analysis, then yeah, that's pretty convincing. That's how science works. Okay. Meta means big and overall. Okay. Like if you're on a Facebook group and you do a meta post is when you complain about the group. How come this group doesn't post about blah, 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 blah? That's a meta post. Or if you're on Twitter, formerly known as Twitter, a meta tweet is something, it's like criticizing Twitter, or if the tweet is about Twitter. That's a meta tweet. Okay, meta means overall. Okay, moving right along. There's a good visual right there of a meta-analysis. Okay, moving right along. All right. A person displays a set of, I'm not going to read that. Okay, the answer is case study. Rare, special, a freak. You study them, just them though, in depth. Okay, so forget about correlational study. We'll talk about that in a second. But student volunteers in a psychology laboratory might not apply to the general population. So imagine this, you're a college professor and you tell your students, look, I got this study I need to do. I want all of you students to get down there and be a part of the study. So you get all these college students down and be a part of the study. But there's a problem with that. The problem is that having a bunch of college students is not the general population. You need to randomly select people to be in your study. So the answer is B. Your people need to be randomly chosen. And so your sample may not be a representative sample. And then you cannot generalize those results. Okay, read that. Okay, so the answer is people lie. So the answer is C, social desirability bias. Okay. People don't always tell the truth. Girls will lie about how much they ate. Okay. All right. Students from a journalism class ask only their friends to participate in a school newspaper survey and neglect to ask the rest of the student body. The answer is sampling bias. You need to ask everybody in your school or a random sample of everybody in your school. You can't just ask your friends. Okay? Then if you do, then you'll have sampling bias. All right. Okay, so Dr. Jones is using the results of several previous studies on weight loss and emotional state. So he's combining the results of many different types of different studies on the subject. The answer is meta-analysis. Okay. All right, read that. The answer is sampling bias. You need to select your participants. You cannot get people to come to you. You have to go to them. Otherwise, you will get sampling bias. So, which is considered a disadvantage of naturalistic observation? Remember, this is true with everything I'm teaching you today. The answer is only experiments identify the cause, or they fail to. But naturalistic observation just says what is there. It doesn't say what caused the behavior. You have to do an experiment to identify the cause. Okay, correlational research. One of the big themes of this class is correlation versus causation. Just because two things go together does not mean that one thing causes the other thing. As you can see, ice cream consumption goes up in July, so does the murder rate. So does that mean that ice cream causes murder? Or that murder causes ice cream consumption? Or does something else cause both? We don't know. You have to do an experiment to know. But correlational research is saying, to what extent does two things go together? Okay? Moving right along. So here's an example of a correlation. Studies show that there is a strong correlation between how many books are present in a child's home and college completion rate. Does that mean that the books cause a person to complete college? Of course not, but they are correlated. When I was a kid, I heard that there was a major correlation between kids listening to classical music and intelligence. And you should have seen all the parents playing classical music to their babies so they would grow up to be intelligent. It's ridiculous. Here's another one. Studies show that people who smoke marijuana have fewer health problems. That is true. That is a correct correlation. But does that mean that marijuana causes you to be healthy? Or does being healthy cause you to smoke? Or does something else cause both? Okay. Honestly, it's probably youth causing both. Young people smoke more and young people are healthier. That's the way that I see it. All right. So keep this in mind. that keep in mind that just because low depression and self-esteem go together, you don't know which way the causation goes. Keep that in mind. All right, moving right along. Now, this is from the pandemic. So you've got all these 5G coverage maps, and then you've got all the coronavirus cases. So I think it's obvious that 5G is causing coronavirus. You see that? You see how people can mistake correlation and causation? Okay. Now, here, look at this. Here's an article from a website. Early circumcision may be a major cause of sudden infant death syndrome. However, when you actually read the article, it says blah, blah, blah can explain a strong correlation. Okay, between circumcision and SIDS, that's sudden infant death syndrome. So again, the person who wrote the title doesn't understand that they're correlated, but it doesn't mean that there's a causal relationship. Okay. All right, moving right along. All right. I need you to know what is a correlation coefficient. There is a number. It's a number between -1 and +1 that describes how strong the correlation is. And is it positive correlation or is it negative correlation? 0 means no correlation. A correlation coefficient of 0 means that those two things have absolutely nothing to do with each other. Let me explain. Okay, so 0.37 means that there is a weak positive correlation between two things. 0 means there is no relationship. 1 means there is a perfect relationship. So here is a perfect positive correlation. It means one thing goes up and the other thing goes up. Here is a negative correlation. Notice that a positive correlation has a positive slope and a negative correlation has a negative slope. Negative correlation means one thing goes up and the other thing goes down, like sleep and anxiety. Okay, one goes up, the other goes down. Well, I don't know, but I know the more you sleep, the less anxious you are, probably. But that may not be a perfect negative correlation, but I believe it's there somewhere. No relationship at all. It's like bicycle purchases in Zimbabwe and mental health of people in New Jersey. They would have nothing to do with each other. So that would be a 0 relationship. Okay. So when you look at a scatter plot, you need to understand, is it a positive correlation? Is it negative? Is it no correlation? And also, the more of a line it makes, the closer the dots are clustered together, the closer it is to a line, the stronger the stronger the correlation, whether it's positive or negative. But if the dots are spread apart, that's a weak positive. How about this? Grades and intelligence. That would be a weak positive correlation. Certainly, more intelligent people would have better grades most of the time. But you know as well as I do, there are plenty of super intelligent people who make awful grades. Okay? So the further they're scattered, the weaker, the closer to 0 it will be. That is a very weak negative correlation. All right. So now let me explain something else here. Which one of these is the strongest relationship? The strongest is the one that is the furthest away from zero. It doesn't matter if it's positive or negative, but it has to be one positive one or less, and it has to be greater than or equal to negative one. So the weakest would be the one that's closest to zero. So E is the weakest because it's closest to zero. B is the strongest because it's the furthest away from zero. But D is invalid because it has to be between 1 and negative 1. Okay, I hope I'm not going too fast. All right, read that. The answer is, notice that it's a positive slope. It's not perfect, but it kind of creates a positive slope. So the answer is B, positive correlation. All right, read that. So look at the data. Look at test 1 and test 2. Does test 1 and test 2 kind of look the same? Are they pretty close together? The answer is yes, since they are fairly close together, so you would have a fairly strong positive correlation. Not a perfect positive correlation, but fairly strong. And it'd be positive because they seem to be in line with each other. A negative correlation would mean that if one went up, the other would go down. But this is a positive correlation. So the answer is C. Now, it's definitely not E because a correlation has to be 1 or less. And it's not 1 because they are different. If the answer is D, they would be exactly the same. All right. Among these, which has the strongest relationship? So the strongest would be the one that's closest to a line. So C would be the weakest. B would be a very weak positive. That would be negative, a weak negative. That would be a weak positive. The answer is E, meaning that they form the closest thing to a line. That's the strongest relationship. Which one of these shows the weakest relationship? The answer is that's the weakest. These are pretty strong. That's the weakest. Okay. All right, read that. The answer is the researcher has incorrectly inferred correlation from causation, similar to what I said earlier. Okay, read that. The answer is delve deeply. Now, this is a tricky one because once you see cause, you think it's an experiment, but that's not what they're really talking about. They don't have an independent variable and a control group. They don't have that. This is not an experiment. It's a case study. When you delve deeply into something, it's a case study. Tricky question. All right, read that. The answer is, that's a cross-sectional study. When you study different sections of people, different age groups, different income groups, that's cross-sectional. All right, read that. The answer is D. 0 means there is no relationship at all. All right, read that. The answer is, and that experiment, let me read this to you. Experimental research differs from correlational research in that experimental research, there. Remember what I said about the experiment. The answer is, experiments reveal a causal relationship, not correlation. Only the experiment establishes causation. All right, analyze results. So this is some like 8th grade statistics that you need to be able to do. I promise you, you need to be able to do this. You need to know how to calculate the median, the mean, and the mode of any kind of set of data. Now, the mode is the one that's the most common, okay? So 9.6 appears 3 times, so that's the mode. The mean is when you add it all up and divide it by the number of datum that you have. The median, think of it this way. When you're driving down the road, the median is in the middle of the road. What is the median? Well, if it's an odd number, then you could just pick the middle one. But if it's an even number, there's 10, so it's an even number. You have to take the middle 2 and divide it. You got to list them least to greatest. I'm not saying that this would be easy to do, but you have to list them least to greatest and then average the middle 2. Average number 5 and number 6. And if the set is 10 pieces. Okay? All right, this is important. Write this down. Standard deviation. How far apart is the data? So if I were to, what is the standard deviation of age in a high school? Well, if you have 9th graders, 10th graders, 11th graders, and 12th graders, the standard deviation would be about 1 year. On average, everyone is about 1 year apart, approximately. But if you were to go somewhere outside of high school and go to, say, Six Flags or something, or Disney World, then you have a much larger standard deviation. You've got 80-year-olds, you've got 2-year-olds, you've got 20-year-olds. You have a much larger standard deviation at Disney World when you're asking about ages. So standard deviation is basically how far apart, on average, is the data. Okay. All right. What is the median? Put these in order, least to greatest. Pick the middle one. The answer is 5. So you'd have to average 6 and 4 to make 5 in this case. All right, do this one. The answer is not the easiest question, but the answer is D. How far apart from the mean is everything? On average, how far apart from the average is every piece of data? That's really what standard deviation is. When you take statistics in college, you can learn to calculate this yourself. All right. A mean of 80 with a standard deviation of 4. Which of the following scores is within 1 standard deviation of the mean? Okay, so the standard deviation is 4. The mean is 80. So your answer needs to be between 84 or 76, within 1 standard deviation. So the answer is, boom, standard deviation of 4, so 1 standard deviation below would be 76. 1 standard deviation above would be 84. So your answer had to be within that range. Sorry if I'm going too fast. I'm sorry. All right. What is the range of her scores? The range is when you take the biggest number and subtract the smallest. So the range is 15. What is the median? Okay, 1, 2, 3, 4, 5, 6, 7, 8. So you have to average the middle two. The median is 9.5. All right. What is the mode? Mode is the most common one. The mode is 7. What is the mean? Add it all up and divide by 10. You add it all up, you get 64 divided by 10, and you get 6.4. Remember, when you divide a number by 10, just move the decimal back one place. All right, write this down. What is statistical significance? Okay, so I probably should have taught this in the experiment video, but oh well. When you do an experiment and your results are kind of lame, okay, you wonder, were the results the cause of just random variations in nature, or did the independent variable actually cause the dependent variable? Otherwise, if it's not statistically significant, then it's just due to random variation in nature. I'll give you an example on the next slide. So let's say I want to know if giving quizzes will actually increase test scores. Okay, so I divide everybody up into randomly selected groups, and then I say, you guys do quizzes and you guys don't do quizzes. And then I find that the quizzes group got a 68.5 mean test score, while the non-quizzes group got 64.75. Now, let me ask you this. Is that a big enough difference to really mean that the quizzes caused the difference? I don't know. This is just made up data. But the point is that what if this difference is just random variation in nature? What if the quizzes isn't doing anything? Okay, something to think about. Is the difference meaningful, or is it just random chance? Is it statistically significant? All right, read that. The answer is the difference was not statistically significant. That means the difference occurred by chance. Okay. Bias. You need to understand that research can be biased. If you get a study that says milk is really good for you, and then you find out that the American Dairy Association paid for that study, then that's bias. That's a problem. In experimental psychology, a significant difference refers to, all right, the answer is not due to chance. It is statistically significant, so it's not due to chance. All right, write this down. So if you are going to do a scientific study, you have to go to a college, you got to go to an IRB, an institutional review board, and these people are going to review your methods. They're going to make sure that you're doing it right. They're going to make sure that you clearly defined your variables, and they're going to make sure that you don't have any ethical problems, ethical violations. They don't want you just throwing acid in monkeys' faces for no reason. Okay, that's what the IRB does. If you're going to do studies on animals, you got to have a clear scientific purpose. You got to take care of the animals, and you must minimize suffering. Now, this is very, very important. Coercion. Participation must be voluntary. You're a professor, you can't just tell your students, go be in this study or you're going to fail the class. You can't do that. Informed consent, permission, consent, permission. They must know they are involved in research and give their consent or their permission. If they are deceived, what they did consent to must be similar to what they are actually studying. Obviously, you need to minimize trauma. You don't want to hurt people psychologically or physically. You must have confidentiality. You don't want to do a study and then publish it in a local newspaper with everybody's names who participated. That is a violation of people's privacy. You cannot do that. And finally, debriefing. When the study is over, you have to tell them what they were studying. You have to tell the people the results of the study and why they did it that way. And the people need to be able to contact a researcher and ask questions. Okay? When you're studying minors, people under the age of 18, you need informed assent. It's a process that allows minors to agree to participate in clinical trials or research when they are not legally able to give informed consent. So you could do studies on kids, and you don't need parent permission, but you do need something called informed assent. I don't really know anything about that. Okay. All right. You need to be able to read something like this and be able to learn, find out what is the ethical violation, what is the independent variable, what is the dependent variable. Okay. And if you mess with their self-esteem, that's an ethical violation. Stop messing with people. Okay. All right. I'm going to hit pause if you're not on Edpuzzle. Which of the following is an ethical consideration that was most problematic for the study? The answer is, all right, so if you're going to do preteens, you got to have informed consent. Okay. To prevent the ethical abuse in psychological research, the APA has suggested that the answer is you must avoid deception. That's weird to me because people deceive people all the time. A researcher uses debriefing when she does what? The answer is, after the study is over, explain the true purpose. That's debriefing. It happens afterward, not beforehand. Okay. All right. All right. That's it. Thank you.